So what I'd like to do now is wrap up the discussion about Java ReentrantLock. And what we'll do here is talk about the usage considerations to think about when you're using a ReentrantLock. So one thing to remember is that a ReentrantLock always has to be used in a fully bracketed way. And that means that the thread that acquires the lock must be the thread that releases it. Unlike the semaphores and the condition objects, you have to bracket the access of a ReentrantLock. This design, the way you do this kind of thing, is known as the scoped locking pattern. You can read about that here. And in Java, this is implemented by synchronized methods and statements. So you can see when the open curly brace is hit here, that will go ahead and acquire the monitor lock. And then when the closed curly brace is hit, that releases the monitor lock. This pattern is also commonly used in C and C++, or sorry, in C++ and C# via constructors and destructors. So typically what you do is you basically write a little guard object that acquires something in its constructor, does some stuff with the lock held, and then when the destructor is called, when it goes out of scope, it releases the resource. This is called the resource acquisition is initialization pattern or idiom in C++ and C#. ReentrantLocks can be tedious and error-prone to use due to a couple of traps and pitfalls. These are similar to the ones we talked about with semaphores. One thing to do is to forget to release a lock. So you have a lock acquired, and then you have some return statement, but you forget to release a lock. The easiest way to remember to do that, of course, is to use a try finally block. But another mistake is to forget to acquire the lock. So in that case, you'll release it, but you won't acquire it. Another problem is to hold a lock for too long. Like you grab a lock, go into some long loop that doesn't require the lock, and you forget to release it. Yes, Ann?
Will the compiler let you release it without acquiring it?
Well, the question is, will the compiler keep you from doing something like this? Absolutely, it doesn't know. A really, really, really good compiler or a good analysis tool could analyze the locking protocols and give you a warning saying, oh, you forgot to release this lock, but many compilers won't go to that amount of trouble. A tool might be able to do that, though, some kind of analysis tool. And why does the compiler not know? Because the compiler, unless it's a really, really smart compiler, doesn't really recognize the semantics of lock. As far as it knows, these are just method calls. And it doesn't know that this is some special protocol that has to be obeyed. And that's because something like a ReentrantLock is not a built-in feature in the language. It's a library. And so the compiler would have to know an awful lot about the semantics of locks to know that it should check for those conditions. Again, a static analysis tool would tell you that. And then the other thing to do is to access a resource without acquiring a lock for it and have that resource be contended for by multiple threads. So those are the kinds of things that will get you into trouble with ReentrantLocks. So that's the end of that section. Just a quick sort of recap of something to kind of tie a little bow together about all these topics.